Okay, guys, we're going to, let me get this up to full screen. Linear inequalities, which is 6-5. Identifying solutions of a linear inequality. The question is the ordered pair a solution of y is greater than x minus 3? They're giving us two examples here. This one is x, this is y. So let's do one at a time. We're going to substitute 1 in for x and 2 in for y to see if this actually works or not, if it's a solution. So put your 2 in for y, substitute, and 1 in for x, and then simplify. 1 minus 3 is negative 2. Is 2 greater than negative 2? Yes, it is, so it's true. Therefore, 1 comma 2 is a solution. Second question, same idea. They're switching the ordered pair on us, so now we're going to substitute negative 7 in for y, negative 3 in for x. It's negative 7 is greater than, negative 3 minus 3 is negative 6. Is negative 7 greater than negative 6? That is false. Therefore, negative 3 comma negative 7 is not a solution. Okay, so that's checking to see if a point, any particular point, they could give us any of them, is actually going to work in the problem. Remember this screen, remember what we've just done, and go back if you need to, because when we get to the next screens, we're going to use a checkpoint to see if it comes out true or false like these, but the one we're going to use most of the time is 0, 0. Two major differences when graphing a linear inequality on a graph. A solid line, which would look something like this, means that you have the equal sign under the inequality, the half equal sign. If it's a dotted line, it means that it actually doesn't include that number, and you would only have the greater than or the less than symbol. There would be no equal sign under it. I kind of abbreviated down here and summarized what the book was talking about, which is how we figure out which side of the line you're actually going to shade on. You're going to pick a point. Typically, using 0, 0 is the easiest point to pick. And then what you're going to do is you're going to substitute, this doesn't mean subtract, it means substitute the point 0, 0 into the inequality. Now, the only time you can't use 0, 0 is if your line actually goes through the origin at 0, 0. Then you'll have to pick a different point. Just pick small numbers to make it work easier for you. If your 0, 0 comes out as true, then you're going to shade that point side. If 0, 0 comes out as false, then you're going to shade the other side, because the other side would be the true side. And this is going to make more sense once I actually do some examples. Down here it says, remember, flip the sign, the inequality sign, if you ever multiply or divide both sides by a negative. That doesn't happen often, so sometimes it trips us in equations or inequalities, excuse me, when we haven't seen it in a while. All right, let's look at a couple simple inequalities to graph. You're going to need a straight edge. You're going to need graph paper for this the rest of the chapter. We have graph, it says graph x is greater than negative 4. So that means because they only have the x, we're going to have either a horizontal or vertical line. Go find negative 4 on the x-axis, which would be 1, 2, 3, 4, would be this point right here. It's going to be a vertical line at x is greater than negative 4. Understand that this inequality does not have an equal sign in it, so it's actually going to be a vertical dotted line like I've drawn here. Then you have to figure out what side to shade. Well, if you actually put 0, 0 in as your checkpoint, the only number you're actually substituting in is for x would be, is 0 greater than negative 4? That's this point we're checking, 0, 0. 0 is greater than negative 4, so that means we're going to actually shade. And when you shade, You shade starting at the line everything that is on the true side, which is this side, because this is true, and this must be false. So I'm going to go ahead and shade. When you guys shade, don't get carried away with shading because it's going to get sloppy when we get into the next section. Looking at the, whoops, I also forgot to label it. All right, the next graph says graph y is less than or equal to 2. Well, it says find 2 on the y-axis, which is right here. This is going to end up being a horizontal line. It has the equal sign under it, so that means when I go to draw my line, make sure that your line is solid, like this. Make sure you label it. And now we have to do our checkpoint. You can pick 0, 0 because 0 does not go through the origin. So I'm going to use 0, 0 again, which will happen for you about 90% of the time. You're only substituting in for the y because there is no x. Is 0 less than or equal to 2? Well, yes, that's true. So the point you picked happens to be on the true side, which means the other side of the line is false. You always shade the true side. Did you hear that? Always shade the true side. That's very, very important. All right, these are two graphs where you were missing either the x or the y. Let's look at a graph where they actually have the x and the y in both. Make sure you have graph paper. You'll probably have to put me on hold here because you'll have to set your x-y axes up. Don't forget to put your arrows and don't forget to label it. This is a little bit blurry, but it says y is less than or equal to 1/2 x plus 1. This is in slope-intercept form, which is y equals mx plus b. So I know that my slope, is 1/2, and that my y-intercept is 1. So if I go to my graph and I plot my y-intercept at 1, which is my starting point on the y-axis, and I work my slope, just like I learned in the last chapter, I'm going to go up 1 to the right 2, 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 or I could go in reverse, down 1 to the left 2, down 1 to the left 2. Now, when I connect my line, notice that there's an equal sign under here. So that means when I connect it, I'm going to have a solid line. So it's got to be solid. Try to go all the way through your graph. Don't forget to label it. Y is less than or equal to 1/2 x plus 1. Now, the second part of doing this is to figure out which side of the line we shade. And the reason why we have to shade is because we're not talking about an equation. We're talking about an inequality here. So I'm going to use my checkpoint. And I can pick 0, 0 because 0, 0 is not on my line. I'm going to substitute 0 in for x and 0 in for y to figure out, is this side the true side or is it the false side? So I'm going to substitute 0 is less than or equal to 1/2 times 0 plus 1. 1/2 times 0 is 0, and 0 plus 1 is 1. Is 0 less than or equal to 1? Yes, that is true. So that means this side is the true side, and the other side must be the false side. Remember what I said before. Always shade the true side, which is this side of the line. You're going to have to go on an angle because you have a slope of 1/2 with your shading. So there it is. Let's go ahead and try this one. This one is a little bit tougher because we're giving it to us in standard form. Let's unscramble it and get it into slope-intercept form. It's not the only way I have to do it. I actually could have figured out what my x and y intercepts were and plotted those 2 points and then connected with my line, a dotted line. Divide everything by 2. We get y is greater than -3 halves x minus 8 divided by 2 is 4. So that means that my slope is -3/2 and my y-intercept is -4. This part should come fairly easy to you because we have done this already. I hope, anyway. Here's your y-axis and your x-axis. I'm arrowing everything. Start at -4 on your y-axis, and your slope says go down 1, 2, 3, to the right 2. It's going to end up tilting to the left, which is good because our slope is negative. Or we can go up 1, 2, 3, to the left 2. We're going to connect these points with a dotted line because there's no equal sign. So when you do this, don't forget, dotted versus solid, big difference here. Don't forget to label it. Always label using the original equation or inequality. Now, the second part you have to decide that's different than graphing equations is which side to shade it on. That's using our checkpoint. Now, can I use 0, 0 for my checkpoint? Yes, because it's not on the line. So I'm going to just substitute 0, 0 into my original equation. And I end up getting 2 times 0 is 0, 3 times 0 is 0, 0 plus 0 is 0. Is 0 greater than -8? That's true. So therefore, my 0, 0, which is on this side of the line, is true. The other side of the line is the false side. So that means, don't forget, always shade the true side. Try not to get carried away with coloring in when you shade, because it ends up sometimes becoming too sloppy to look at. All right, the last part of this is when they give you a word problem. We're actually not going to graph this, but let's just look at it. It says an interior decorator is going to remodel the kitchen. The wall above the stove and the counter is going to be redone as shown. The owners can spend $420 or less. Write a linear inequality and graph the solutions. What are the 3 possible prices for wallpaper of tiles? So tiled area is 12 feet squared and wallpaper is 24 feet squared. So we're going to let's let x equal the cost of paper, wallpaper, and we'll let y equal the cost of tile. So that means we're talking about paper, we have to cover 24 feet squared. That's 24 square feet, which is 24, times x dollars per square foot, plus 12 feet squared for tile, times the amount of money for the cost of tile has to be less than or equal to $420. Now, they also wanted us to graph it, but I'm going to go ahead. You guys can try graphing it on by yourself. My recommendation would be to find the x and y intercepts. When you find the x-intercept, you're going to put 0 in for y. And when you find the y-intercept, you're going to put 0 in for x. When you find your x and y-intercepts, go ahead and graph it. You're going to end up with 2 points on your graph, connect it with a solid line, and then do your checkpoint to see how you shaded it.